Okay, this one should actually be pretty short. So conjugates, what is a conjugate? So actually what I'm doing is I'm bringing back the idea of difference of two squares from the factoring video. If you wanted to factor a squared minus b squared, the factorization for that is a plus b times a minus b. Now, if you distribute that back through, right, you can kind of work this out. A squared minus ab plus ab and then minus b squared, right? But then what happens with the AB terms is they do in fact cancel. And you're left with a squared minus b squared. So yeah, we're good. We see that that works. So what's the point? Well, guess what the conjugate is? It is the same two terms with the opposite operation. So if you are looking at a plus b, the conjugate of a plus b is a minus b. If you're looking at a minus b, the conjugate of a minus b is a plus b. It's really that simple. Okay. So what I've done here is I've written out two examples of things that I want you to state the conjugate for, and then we're going to multiply these things by their conjugate. Okay. And then we're going to simplify. All right. And so for the first two examples, we're going to do a little bit more work than what we're going to expect of you. And then in numbers 3 and 4, I'll show you how you can kind of skip over some of the work. Okay. So the conjugate of x plus 5 is literally x minus 5. It's just same two terms, change the operation from addition to subtraction. So now let's go ahead and multiply x plus 5 times its conjugate, x minus 5. All right. And now if you're thinking, oh, difference of two squares, great. That's where we want you to go. But maybe you don't see that right away and you go ahead and start distributing. X times x, you got x squared. X times negative 5, negative 5x. X times positive 5, positive 5x. And then 5 times negative 5, negative 25. But then negative 5x plus 5x cancels, and there we have it, difference of two squares. The square of x, the square of 5 in a difference. Okay? So I put a root on here. Big deal, we got this. The conjugate of the square root of x minus 4 is going to be the square root of x plus 4. Pretty straightforward. So we are going to go ahead and multiply root x minus 4 times root x plus 4. And notice the minus 4 and the plus 4 are not underneath the root. That's very important that we see that. Okay. So we have root x times root x. So that's root x squared plus 4 times root x minus 4 times root x minus 4 times 4, so minus 16. Again, 4 root x minus 4 root x, those two middle terms cancel as they always should. If I square a square root, that leaves me with x minus 16. It is still difference of two squares. It's root x squared minus 4 squared. Okay, so now what we're going to do, same thing, except we're going to skip over the part where we get the the outer and the inner terms from the foiling. That's the acronym for distributing a binomial, right? With another binomial. We're going to skip over that because we know they will cancel, and we're just going to utilize our difference of two squares formula. I'm actually going to keep this right in front of us for our next two examples. Kind of shortcut it, but legally shortcut it. Let's be careful with that. All right, so the conjugate of something plus another something is something minus that other something. So root x plus 1 minus 3. Okay. So now we want to multiply these together. Root x plus 1 plus 3 times root x plus 1 minus 3. So the a in this case is the root x plus 1. So we need root x plus 1 squared minus the b in this case is 3. So we need 3 squared. So I just did a squared minus b squared. That's it. And when I square a square root, that cancels, leaving me with x plus 1. When I square 3, I get 9. And I can clean this up a teeny bit more because 1 minus 9 is negative 8. One more like this, and then we're going to do what's called rationalize, okay? So the conjugate here, instead of 4 minus the root, we're going to have 4 plus the root. Okay, so 4 minus square root of 5 minus x times 4 plus the square root of 5 minus x. Same idea. A is 4, a squared, minus b is the square root of 5 minus x, b squared. A squared minus b squared. 4 squared is 16. If I square a square root, that cancels, but I need to be careful because I'm subtracting this entire result. So I need parentheses. And then I'm going to distribute through the negative, which gives me 16 minus 5 plus x. And 16 minus 5 is 11. So I get 11 plus x. And if you don't like that, I know some people would rather write it as x plus 11. Either way is fine. All right, now in the last two problems, we have what's a situation where we would ask you to rationalize this, meaning let's try to get that root, that square root out of the denominator, okay? You might also need to rationalize a numerator once in a while. That just means that it starts in the numerator, you want to put it into the denominator. So ultimately, it's just changing the location from numerator to denominator or vice versa of where the root is located. The way we're going to do this is we're going to multiply by the conjugate of the thing we're trying to move, which in this case is x plus 100 minus 10. So I'm going to multiply by x plus 100 plus 10. But I can't just multiply that in the denominator because I'm changing it. I have to multiply by 1, so that also gets multiplied into the numerator, like so. All right, now 1 times anything is just that thing. So we have the square root of x plus 100 all plus 10 in the numerator. And in the denominator, we have the product of something times its conjugate. So again, a, which is the square root of x plus 100 squared, minus b, which is 10 squared. So I just did the same thing that I did up here, I did in this problem. All right, so now we have the square root of x plus 100 plus 10 divided by, if I square a square root, it cancels and I have x plus 100 minus 10 squared is 100, which actually means those 100s cancel. And I am left with, move this a little bit more, the square root of x plus 100 plus 10 all over x. And that's the cleanest version for that. All right, so similar situation over here. We want to eliminate the root from the denominator. So we're going to multiply the denominator by its conjugate, because what we do by multiplying by the conjugate is we square the two terms, getting rid of the square root. But again, whatever I multiply into the denominator, I must also multiply into the numerator, because that's multiplying by 1. So in the numerator, unfortunately, I do have a little bit more going on, but I'm going to leave it in factored form. So x times everything in the second factor. So root x plus 36 all plus 6. And I just left that in parentheses times x. Divided by. And then here I have what I started with times its conjugate. So then I have root x plus 36, that's my a, squared, minus b, which is 6, squared. Let's clean it up a little bit. So I'm going to leave the numerator factored for now. We'll see what happens. See how it plays out. Just copying down my numerator as is. Squaring a square root, I get x plus 36 minus 6 squared is 36. Oh, look at that. I can cancel the 36s. So I have x times the square root of x plus 36 plus 6 all over. Oh, all I have left is x. Well, because x is a factor, I can cancel that. And now I have the square root of x plus 36 plus 6. Now I have to be careful though, because I can only cancel that x if I say x is not equal to 0, because if it was, it would make this whole thing undefined. All right, so anytime you cancel a variable from the denominator, you want to go ahead and make the statement as to what that variable could not be, okay, so that you're not breaking any rules. All right, so these last two examples would be examples of answering the question rationalize, right? Please rationalize the expression. Whereas the others are find the conjugate and multiply. All right.